So look at the problem. Find the equation of the line through the points 1, 2, 3 and 3, 4, minus 5. So we have to find equation of this line in both vector form as well as Cartesian form. Okay. So let us denote the coordinates of first point by capital A. That capital A is equal to 1, 2, 3. Then this implies that the position vector of A, OA bar is equal to A bar is equal to what do you get? 1 into I cap plus 2 into J cap plus 3 into K cap. And B is equal to 3, 4, minus 5. Then the position vector of B, OB bar is equal to B bar. That is equal to what you will get? 3 into I cap plus 4 into J cap minus 5 into K cap. So now we have to find equation of the line passing through given 2 points. So first I am writing vector equation. So vector equation of the line through the points A whose position vector is A bar and B whose position vector is B bar is, so what is the vector equation passing through 2 points? R bar is equal to A bar plus lambda into B bar minus A bar. So lambda is a real number. So thus R bar is equal to A bar. So what is A bar? Vector I cap plus 2 into J cap plus 3 into K cap plus lambda into B bar minus A bar. So this vector minus this vector. So what you will get? 2I cap next plus 2J cap minus 8K cap. So this is the vector equation of the line passing through given 2 points. Next, Cartesian equation. So Cartesian equation of the line through given points A and B is, so what's the formula? X minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So x minus x1. So here what is x1, y1, z1 and x2, y2, z2? x1, y1, z1 are the coordinates of first point. x2, y2, z2 are the coordinates of second point. So x minus x1, x1 is 1 divided by x2 minus x1, 3 minus 1, 2 is equal to y minus y1, y1 is 2 divided by y2 minus y1, 4 minus 2, 2 is equal to z minus z1, z1 is 3 divided by z2 minus z1, minus 5 minus 3, minus 8. So this is the equation of a required line. So next, look at the second problem. Find the angle between the lines L1 and L2 whose DRs are 1, 2, 3 and 4, 5, 7 respectively. So we have to find angle between two lines. DRs of the lines are given. So if I assume DRs of first line are A1, B1, C1 and DRs of second line are A2, B2, C2 and say theta is a angle between given lines L1 and L2, angle between the lines L1 and L2. So what is cos theta? Cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 by root over a1 square plus b1 square plus c1 square into root over a2 square plus b2 square plus c2 square under modulus. So why we are keeping modulus? Because we need to find acute angle. Okay. So cos theta is equal to a1 a2 1 into 4 4 plus b1 b2 2 into 5 10 plus c1 c2 3 into 7 21 divided by root over a1 square 1 square 1 b1 square 4 c1 square 9 into a2 square 16 b2 square 25 c2 square 49. So numerator what will get modulus only, no? So 14 plus 21 35 divided by 9 plus 4 13 13 plus 1 14 root 14 into here 16 plus 49 65 65 plus 25 what you will get 90. So thus further how we can adjust, so or else you stop here 35 you can write this as 3 root 10 so root 14 so orally 3 root 140. So cos theta value, so theta is equal to cos inverse of 35 divided by 3 into root 140. So it is the angle between given lines. So this is the method to find angle between given lines whenever drs of the line are given. So when direction cosines are given, directly you can use cos theta is equal to mod L1 L2 plus M1 M2 plus N1 N2. So next one important note point. Suppose equation of the line is given x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Here x1, y1, z1 denotes what? Coordinates of a particular point, and small abc denotes what? Drs of the line. Then what about x, y, z? That they are the coordinates of any point on the line L. Okay, so this is the equation of the line L. Then x, y, z denotes what? Coordinates of any point on the line. That is a variable point. X, y, z is the coordinates of a variable point on the line L. Now, any point on the line L can be taken as, that means x, y, z values. Suppose if you all are equal to say lambda, then if you equate first and last, then what you will get? X is equal to, directly I'm writing a into lambda plus x1. Similarly, y is equal to, if you equate these two, y is equal to what you will get? B lambda plus y1. And if you equate these two, what you will get? Z is equal to c lambda plus z1. So that means coordinates of any point on the line is of the form. So x1 plus a lambda, y1 plus b lambda, z1 plus c lambda. So remember this point, coordinates of any point on this line should be in this form. Okay, here a, b, c are direction ratios. x1, y1, z1 is a coordinates of particular point on the line L. Okay, so now Next problem, how to find foot of the perpendicular drawn from a point to the line. Okay, so that means you know the point, coordinates of the point, and you know the line equation. How to find coordinates of foot of the perpendicular. Okay, suppose this is the straight line L, whose equation is this, and A is the given point. Say coordinates of A are alpha, beta, gamma. So draw a perpendicular from A to the line L. Then this point, say Q. Then Q becomes foot of this perpendicular. Drawn from which point? A. On which line? L. So as the line equation L is this, this is a Cartesian form now. In vector form, how we can write this equation? R bar is equal to what? A bar plus lambda into B bar. Am I correct? Okay, so A bar components becomes what? X1, Y1, Z1. B bar components A, B, C. That means this is the line parallel to which vector? B bar. So how to find coordinates of Q? So I'm explaining the method. Okay, so if you observe clearly, the vector AQ is clearly perpendicular to L, also the vector B bar. So, and Q is also a point on which Q is a point on what? Line L. So as the Q is a point on the line L, then coordinates of Q can be taken as like this. Am I correct? Or if you take, instead of Q, you take P only, no problem. So P is a what? Foot of the perpendicular drawn from A to the line L. Then coordinates of P becomes like this. Then these becomes the components of P. Then clearly here, the vector AP bar is perpendicular to the vector B bar. Then their dot product will becomes 0. So using this condition, you can find lambda value. The lambda value, unknown lambda value. Using this condition, after getting lambda value, substitute that lambda value in this. Then you'll get the coordinates of P. That is nothing but foot of the perpendicular drawn from given point on given line. Okay, or you can use method 2. So this is a vector form. Now I'm explaining method 2 means it is a Cartesian form. So first you find a drs of AP and a drs of the line. Nothing but drs of the line L is nothing but drs of B bar only. Okay. Then as the line AP is perpendicular to given line L, that means that these two lines, AP line is perpendicular to the line L. Then using the perpendicular condition, what do we have perpendicular condition? A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Using this condition, you will get lambda value. Substitute that lambda value in the coordinates of P. You will get the coordinates of P. So this is the method to find foot of the perpendicular drawn from a fixed point to the given line. Okay. So take one example. So find the foot of the perpendicular drawn from the point 1, 2, 3 upon the line, on the line x minus 2 by 3 is equal to y plus 3 by minus 4 is equal to z minus 5 by 3. Okay, so we have to find foot of the perpendicular drawn from this point to this line. Okay, so first just draw the diagram. So this is the line L, given line. Okay, and this is the given point 1, 2, 3. So through this point I'm drawing a perpendicular. Then let the foot of this perpendicular is P. Then here observe that P is a what? A point on the line. So any point on the line L is of the form like this only. No? Okay, so what is the given line? Solution: x minus 2 by 3 is equal to y plus 3 by minus 4 is equal to z minus 5 by 3. So let it be lambda z. So equating these two and find x value in terms of lambda. What will you get x value in terms of lambda? 3 lambda plus 2. Similarly, if you equate this and this, what will you get y value? Minus 4 lambda minus 3. And z value, if you equate these two, 3 lambda plus 5. That means the coordinates of p can be taken as 3 lambda plus 2. Next, minus 4 lambda minus 3, comma 3 lambda plus 5. So clearly here AP is perpendicular to given line. So first you find drs of AP and drs of the line. So drs of AP. So drs of the line AP. So how to find drs of a line passing through x1, y1, z1 and x2, y2, z2? So what is the formula? x2 minus x1, y2 minus y1, z2 minus z1. Am I correct? So drs of AP, this is A, this is P. Okay, so here I am writing let A is equal to 1, 2, 3. So now x2 minus x1, what will you get? 3 lambda plus 2 minus 1, that is 3 lambda plus 1. y2 minus y1, that is minus 4 lambda minus 3 minus 2, that is minus 4 lambda minus 5. z2 minus z1. So 3 lambda plus 5 minus 3, nothing but 3 lambda plus 3. So these are the drs of line AP. Then what are the drs of line? Drs of given line? 3 minus 4, 3. Okay, so since the line AP, if P is the foot of the perpendicular, P is the foot of the perpendicular drawn from A to the line L, then AP line perpendicular to the line L. Then as these two lines are perpendicular, then what is the condition for perpendicularity? A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So this is A1, B1, C1 and this is like A2, B2, C2. So A1, A2, that is 3 lambda plus 1 into 3. 3 into 3 lambda plus 1 plus B1, B2. B1, B2. So what will you get? Minus 4 into minus 4 lambda minus 5 plus C1, C2. 3 into 3 lambda plus 3 is equal to 0. So simplify 3 into 3 lambda, 9 lambda, 3 into 1, 3, minus 4 into minus 4 lambda, 16 lambda, plus 20, plus 9 lambda, plus 9 is equal to 0. So 9 plus 16, 25, 25 plus 9, 34 lambda, 3 plus 20, 23, 23 plus 9 is 32 is equal to 0. So this implies that if you simplify lambda, lambda value will get minus 16 by 17. So after getting that lambda, so we have to find what? Foot of the perpendicular. That means we have to find coordinates of P. So these are the coordinates of P. In this, what you have to put? Lambda value minus 16 by 17. So just you put lambda value. So if you put lambda value, then foot of the perpendicular. Foot of the perpendicular. P is equal to, what you will get? 3 lambda plus 2. What is lambda value? Minus 16 by 17. So 3 into minus 16 by 17 is minus 48 by 17 plus 2, comma, minus 4 lambda minus 3. So minus 4 into lambda value, what you will get? Plus 64 by 17 minus 3, 3 lambda plus 5. So 3 lambda value is minus 48 by 17 plus 5. So these are the coordinates of P. Simplify this, what you will get? If you take 17 LCM, what will get? 34 minus 48 minus 14. And 17 LCM here, 51. 64 minus 51 is 13. If you take 17 LCM, 85 minus 48, 37. Okay, these are the coordinates of foot of the perpendicular drawn from the point 1, 2, 3 on the line this x minus 2 by 3, y plus 3 by minus 4, z minus 5 by 3. So this is the method to find foot of the perpendicular drawn from given point to the given line. Next, how to find image? How to find image or reflection? How to find image of the point with respect to given line, or how to find reflection of the point with respect to given line. Okay, so suppose given line is L, whose equation is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So let the given point is a, whose coordinates are alpha, beta, gamma. So the reflection of A or the image of A with respect to line L should be placed here. Am I correct? In this region. As A dash is the region, as A dash is the image, if you join A and A dash, this line A dash perpendicular to L, and this point of intersection becomes P becomes foot of the perpendicular, and also this AP length must be equal to PA dash length. Because it is the image, then the distance from A to the line is same as the distance from its image to the line. So AP length is same as A dash P, and P becomes what? Foot of the perpendicular. So to get image of a point or reflection of a point with respect to the line, then first you find coordinates of foot of the perpendicular and use midpoint formula to get A dash coordinates. Because here P becomes what? Midpoint of A dash, then P becomes what? A plus A dash by 2. So using this relation, so you have to find coordinates of A dash. Okay, so from this what you will get? A dash is equal to 2P minus A. So find coordinates of P, that is coordinates of foot of the perpendicular. Okay, suppose the same problem, if they ask image, okay, I am finding directly image, then image of A with respect to the line L is A dash is equal to what you will get? 2P minus A. So 2 into P, P is nothing but foot of the perpendicular. What do you got? Foot of the perpendicular coordinates minus 14 by 17, comma 13 by 17, comma 37 by 17, minus A. So what are the coordinates of A here? 1, 2, 3. 1, 2, 3. So first multiply with 2. What you will get? 2 into minus 14 by 17, 20, minus 28 by 17. Next 2 into 13 by 17, 26 by 17. 2 into 37 by 17, that is 74 by 17, minus 1, 2, 3. So that is, further it is equal to minus 28 by 17, minus 1, comma, 26 by 17, minus 2, next 74 by 17, minus 3. Okay? So subtracting corresponding coordinates only. Now here if you take 17 LCM, what will you get? Minus 17 minus 28. Minus 17 minus 28 is minus 45 by 17, comma. Here if you take 17 LCM, 17 2s are 34. 26 minus 34 is minus 8. So minus 8 by 17. Next, if you take 17 LCM, 17 3s are 54. So 17 3s are 51. 73 is a 51. 74 minus 51. How much? 74 minus 51. 23 by 17. So these are the coordinates of image of the point 1, 2, 3 with respect to given line. So this is the foot of the perpendicular. This is the image. Okay. So to get image of the given point with respect to line, first you have to find what? Foot of the perpendicular. Then if A dash is the image, then P becomes a midpoint of given point and its image. That is, P becomes A plus A dash by 2. From this relation, what is A dash? 2P minus A. So find the coordinates of foot of the perpendicular and substitute in this relation to get the image of the given point with respect to given line. Understood? So because this foot of the perpendicular image, next I'm explaining perpendicular distance. Among these three problems, compulsorily one problem is there. If you observe last 10 years, around 5 years paper, these three model problems is there. So in 3D, you have to concentrate on the theorems or statements like formulas and also methods. So if you can learn the methods and statements and a little knowledge on concepts, then 3D geometry was a very easy topic. So next problem. So find the length of perpendicular or perpendicular distance from the point 0 to minus 1 upon the line x by 3, y minus 2 by 4, z minus 3 by minus 5. So find the perpendicular distance from the point to the line. Find the distance of the point from the line L. So suppose this is the line L. So this is the given point 0 to minus 1. Say this point is A. So draw the perpendicular from A upon the line. Let foot of the perpendicular is P. Then the distance between A and P, or the length of this line segment AP, is the perpendicular distance drawn from A upon the line L. So this problem can be done in two different ways. So first I'm explaining method 1. So we have to find length of AP. Let it be D. So we have to find D value. So the length of AP is the perpendicular distance from the point A0 to minus 1 upon the line L. Okay, so solution. So let the given coordinates, let the given point, I'm denoting it by A0 to minus 1. Okay, so what is the line equation? X by 3 is equal to y minus 2 by 4 is equal to z minus 3 by minus 5. So let it be lambda. Then what you will get? X value 3 lambda, y value 4 lambda plus 2, z value minus 5 lambda plus 3. So that means the coordinates of P can be taken as 3 lambda, 4 lambda plus 2, minus 5 lambda plus 3. Okay. So particularly if AP is sorry, if P is the foot of the perpendicular drawn from A upon the line, then AP is the perpendicular to line L. So first you find AP drs, then you find drs of line L, use the perpendicular condition, then you will get lambda. Okay, so first I'm finding drs of AP. So what you'll get drs of AP? So drs of AP becomes what? So this is P coordinates, these are the A coordinates. So drs of AP, so 3 lambda minus 0, 3 lambda, 4 lambda plus 2 minus 2, 4 lambda, minus 5 lambda plus 3 minus of minus 1 plus 1, that means minus 5 lambda plus 4. Next, what are the drs of line? So drs of line L are 3, 4, minus 5. So clearly from the diagram, the line AP perpendicular to the given line L. Am I correct? Then what is the condition? Perpendicular condition we have A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So this is A1, B1, C1. This is A2, B2, C2. A1, A2. 3 lambda into 3. 9 lambda. B1, B2. 4 lambda into 4. 16 lambda. C1, C2. Minus 5 into minus 5 lambda plus 4. That means 25 lambda minus 20 is equal to 0. 25 lambda minus 20 is equal to 0. So 9 plus 16, 25. 25 plus 25, 50. So 50 lambda minus 20 is equal to 0. So if you simplify lambda value, you will get 2 by 5. So don't substitute lambda value 2 by 5 in P, because here it is required to find distance, not required to find footer. So then directly you consider AP. D is equal to what? AP. So that is distance between the points A and P. So it is square root of what you'll get? x2 minus x1 whole square. That is 3 lambda minus 0 whole square. 9 lambda square plus y2 minus y1 whole square. So I'm finding distance between P and A. Okay, using distance formula. x2 minus x1 whole square. y2 minus y1 whole square. That is 16 lambda square plus z2 minus z1 whole square. That is by minus 5 lambda plus 3 minus of minus 1 plus 1. So minus 5 lambda plus 4 whole square. So it is equal to square root of, but what is lambda value? 2 by 5. Substitute here. 9 into 2 by 5 whole square plus 16 into 2 by 5 whole square. Or you do one thing. So 9 lambda square plus 16 lambda square is what? 25 lambda square. But lambda square is what? 2 by 5 whole square plus minus 5 into lambda, 2 by 5 plus 4 whole square. Okay, so 25 into 2 by 5 whole square is 4 by 25 plus here 5 get cancelled, minus 2. Minus 2 plus 4 is 2. 2 square is 4. 25 get cancelled. So 4 plus 4, 8. Root 8 value is 2 root 2 units. So this is the method 1. So this is the method 1 to find perpendicular distance from the given point to the given line. So just like foot of the perpendicular, how you did? Till here is as it is. If you want to find foot of the perpendicular also, till here as it is. If you put lambda value 2 by 5 in P, you will get the coordinates of P, which are what? Coordinates of foot of the perpendicular. But as you need to find distance, don't put lambda value in P. Directly find distance between A and P. Okay, so using distance formula, then you substitute lambda value. Because if you put P value 2 by 5 here, again simplifying, again finding distance is a lengthy procedure. Okay, but because in this problem we required is what? Finding only perpendicular distance. Then method 2. Method 2. So this is the line. L. So this is the given point A, 0, 2, minus 1. So draw the perpendicular. So P is foot of the perpendicular drawn from P to the line. But a given line is passing through which point? So this line equation can also be written as x minus 0 by 3, y minus 2 by 4, z minus 3 by minus 5. So here what is x1, y1, z1? 0, 2, 3. That means this is the line passing through. The line L is passing through the fixed point what? 0, 2, 3 and parallel to the vector B bar. Okay, parallel to the vector B bar. The components of B bar becomes what? 3, 4, minus 5 only. Na? So components of B bar becomes what? 3, 4, minus 5. That means 3i cap plus 4j cap minus 5k cap. Okay. So now join A and B. Join A and B. So let the angle between AB and the line L is theta. The line angle between AB and the line is theta. So then this theta becomes angle between the vectors AB bar and B bar also now because the vector B bar is parallel to what? L. So here what is theta? Angle between the vectors AB bar and B bar. Okay. So using distance formula you can find AB length. Okay. Then but here required is what? AP. Required is what? AP. So first I'm finding PB. So what is PB here? It is the projection of AB on the line on the vector B bar. So this PB becomes projection of AB bar on B bar. Okay. So what is AB bar vector? What is AB bar vector? So AB bar vector is what? OB bar minus OA bar. That is 0 minus 0, 0 I cap. 2 minus 2, 0 j cap. 3 minus of minus 1, 3 plus 1, 4. So 0, 0, 4. Nothing but 4 k cap. So projection of AB bar and B bar, what is the formula? AB bar dot B bar by mod B bar. So if you do that, AB bar dot B bar, that is 4k cap dot 3i cap plus 4j cap minus 5k cap divided by modulus of B bar, square root of 9 plus 16 plus 25. So better you keep under modulus. So PB should not be negative. Na? So what you get numerator 4 into minus 5 minus 20 divided by root 50. Root 50 is nothing but 5 root 2 under modulus. So 5 4s are 20. 4 by root 2 is 2 root 2. This is PB. Then using distance formula you can find AB also. So distance between A and B. What you will get? 4 units. But we required to find what? AP. So using Pythagoras theorem, AP square is equal to what you'll get? This AP square is equal to what? This AB square minus PB square. What is AB square here? 16 minus, what is PB square? 2 root 2 whole square, nothing but 8. 16 minus 8 is 8. So AP square is 8, then AP is equal to root 8, nothing but 2 root 2. So AP is equal to what? 2 root 2. That is the perpendicular distance from the given point to the given line. So these are the two different methods. You can apply any one of the method. But my suggestion is better you go for first method, because if you want to find foot of the perpendicular or image, then you have to do till this. So that's why my suggestion is better you apply first method. Okay. But also better learn method 2 also. So next, look at the example 5, page number 30.5. Example 5, 30.5. So it is given that show that the lines whose direction cosines are given by L plus M plus N is equal to 0 and 2Mn plus 3Lm minus 5Ln is equal to 0. 5Lm, this is Ln only, 3Ln minus 5Lm is equal to 0 are at right angles. So that means there are two lines whose direction cosines are satisfying these two relations. Now we have to show that those two lines are perpendicular to each other. So here we need to show that what? To show that those two lines are perpendicular, what is the perpendicular condition in terms of direction cosines? L1, L2 plus M1, M2 plus N1, N2 is equal to 0. So to show that those two lines are perpendicular, it is enough to show that this sum is equal to 0. So here no need to calculate L1, M1, N1 value and L2, M2, N2 values. We have to find what? This sum L1, L2 plus M1, M2 plus N1, N2, and we have to show that this sum is equal to 0. So solve the given equations. So this is the one. So from equation 1, L can be written as what? Minus M minus N. Let it be equation 1 and this is equation 2. So put this L value in equation 2. Put that L value in equation 2. Then what you will get? 2Mn plus 3n into L minus M minus N minus 5M into L minus M minus N is equal to 0. So 2Mn multiply minus 3Mn minus 3n square plus 5m square plus 5mn is equal to 0. So 5m square, 2mn minus 3mn plus 5mn. So 2 plus 5, 7, 7 minus 3, 4, minus 4mn minus 3n square is equal to 0. So here L1, L2, M1, M2, N1, N2 is equal to 0 can also be written as like this now. If you common N1 and N2, what you will get? L1, L2 by N1, N2 plus M1, M2 by N1, N2 plus 1. Okay. So here I am doing what? Throughout the equation I am dividing by n square. If I divide with n square, what I will get? 5m by 5 into m by n whole square dividing by what? N square. Then minus 4 into m by n minus 3 is equal to 0. So clearly it is a quadratic equation in m by n. Am I correct? It is a quadratic equation in m by n. So let the roots of this quadratic equation are m1 by n1 and m2 by n2. So if L1, M1, N1 are direction cosines of first line, L2, M2, N2 are the direction cosines of the second line, then M1 by N1 and M2 by N2 become the roots of this equation. Now to get this quantity, just you need to consider what? Product of the roots. So what you will get? Product of the roots M1 by N1 into M2 by N2. C by A only. Na? So what is C value? Minus 3 by A value 5. So thus M1, M2 by N1, N2 is equal to minus 3 by 5. Let it be equation number 3. Now to get L1, L2 by N1, N2 value, you subject M value in this equation. So from that equation, M value what you will get? Minus L minus N. You put in equation 2. If you put M value minus L minus N, minus L minus N here, what you will get? 2n into M. M is minus L minus N plus 3L N minus 5L M. M is minus L minus N is equal to 0. So multiply, what you will get? Minus 2ln minus 2n square plus 3 ln plus 5l square plus 5 ln is equal to 0. So that equation can also be written as 5l square, 5l square. So 5 plus 3, 8, 8 minus 2, 6, plus 6 ln, next to minus 2n square. So same, you divide this equation by n square, then what you'll get 5 into L by n whole square, minus 6 into, plus 6 into L by n, minus 2 is equal to 0. So clearly it is a quadratic equation in L by n. So let the roots of this equation are L1 by n1 and L2 by n2. Now to get this quantity, I have to consider product of the roots. So that is L1 by n1 into L2 by n2 is equal to product of the roots. What will get? Minus 2 by 5. So substitute here. So now you consider L1, L2 plus M1, M2 plus N1, N2, which is same as this. So that is equal to N1, N2 into L1, L2 by N1, N2 value minus 2 by 5. M1, M2 by N1, N2 is minus 3 by 5 plus 1. So minus 2 by 5 minus 3 by 5 is minus 1. Minus 5 by 5 minus 1. So minus 1 plus 1, 0. So 0 into N1, N2, 0. So that's what we have shown. L1, L2 plus M1, M2 plus N1, N2 is 0. As this sum is 0, this implies that what we can conclude? The given lines are perpendicular to each other. Means the direction cosines of two lines satisfying these two relations, those two lines are what kind of lines? Perpendicular lines. So next we look at page number 30.6, first problem. So it is given the projection of line segment on x, y, z axis in three-dimensional space are 2, 3, 6 respectively. Then find the length of line segment. Okay, suppose the ends of the line segment are A and B, whose coordinates are, let it be x1, y1, z1 and x2, y2, z2. Okay, page number 30.6, first problem. Check your understanding in that first problem. So let the line segment is AB, whose coordinates are x1, y1, z1, x2, y2, z2. So given that the projection of this segment AB on x-axis is 2, on y-axis is 3, on z-axis is 6, then we have to find the length of this segment AB. Suppose this is the, say, x-axis, okay, so y, and this is z, this is O. So draw a perpendicular from A on the x-axis, say let it be L. So from B, draw a perpendicular on x-axis, say it is M. Then draw the perpendicular from A upon BM, let it be N. And let it be this angle theta. Then this AN or this LM is what? Projection of AB on x-axis. As the coordinates of A are x1, y1, z1, then coordinates of L becomes x1, 0, 0 because it is a point on x-axis and we have drawn perpendicular A on x-axis, and M is a perpendicular, M is the foot of the perpendicular drawn from B on x-axis. As the coordinates of B are x2, y2, z2, coordinates of M becomes x2, 0, 0. Now, projection of AB on x-axis is the length of AN, which is equal to LM. So that is equal to what you will get? So what is the distance between L and M? It is nothing but x2 minus x1. Am I correct? Using distance formula, you will get what? x2 minus x1 whole square plus 0 minus 0 whole square plus 0 minus 0 whole square. That is finally what is left? Square root of x2 minus x1 whole square. So which is equal to what? Modulus of x2 minus x1. And according to the question, this value is equal to what? 2. So this is the formula, projection of a line segment on x-axis. Similarly, projection of projection of AB segment on the line y-axis. So on x-axis, what you got? Modulus of x2 minus x1. So on y-axis, what will you get? Modulus of y2 minus y1. According to the problem, it is equal to what? 3. Am I correct? Similarly, projection of AB on z-axis. What will you get? Modulus of z2 minus z1, which is equal to 6, according to the given condition. But we have to find the segment length AB. So the segment length AB is equal to distance between the points A and B. So we have to find length of this segment. So length of the segment is equal to distance between A and B. So using distance formula, what will you get? Square root of, what is the distance between these 2 points A and B? Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So that is equal to square root of x2 minus x1 whole square. What we got? X2 minus x1 value 2. So x2 minus x1 whole square value is 2 square. y2 minus y1 is 3. Its square is 3 square. z2 minus z1 is 6. Its square is 6 square. So if you simplify, you will get square root of 49, which is equal to 7. Okay. So that means just you have to find square root of sum of the squares of those projections on coordinate axis. Gives the length of the segment AB. Okay. So next, one more problem. If length of projection of segment AB on coordinate axis are 12, 3, K respectively, and AB is equal to 13, then what is k square minus 2k plus 10? So this kind of problems they will ask for integer type questions. Okay. So projection of AB on x-axis is given what? 12. So what is the projection of AB on x-axis? Modulus of x2 minus x1 only na? From this problem we proved already. So this value is given 12. And projection of AB on y-axis, that is modulus of y2 minus y1 is equal to 3. And projection of AB on z-axis, that is modulus of z2 minus z1 value is how much? K. And also given the length of line segment AB is equal to how much? 13. So using this relation, AB is equal to what? Square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That is, it is the square root of sum of the squares of projections of AB on the coordinate axis. So this AB is equal to square root of sum of the squares of these projections on the axis. That is 12 square plus 3 square plus k square. This is the length of line segment. Okay. But it is equal, according to the question, it is equal to what? 13. So squaring on both sides. So 12 square is 144. 3 square is 9 plus k square is equal to 13 square is 169. So if you simplify, what you'll get, k square is equal to 16. So k is equal to how much? 4. Now what do we have to find? K square minus 2k plus 10 value. Okay, k square is how much? 4 square minus 2 into k, 4 plus 10. So 16 minus 8 plus 10. So answer is 18. Understand? Time over. So next, look at page number 30.6, example 6. Example 6, page number 30.6. So find the area of the triangle whose vertices are given A. A is equal to 1, 2, 3. B is equal to 2, 1, minus 1. C is equal to 1, 2, minus 4. This is a 2 minus 1, 1. 2, 1, minus 4. So find the area of the triangle. 1, 2, minus 4. So just I am giving hint. So first you find AB bar vector, that is OB bar minus OA bar. OB bar minus OA bar. What do you get? 2 minus 1, minus 1 minus 2, minus 3, 1 minus 3 minus 2. That is I cap minus 3j cap minus 2k cap. Then find AC bar vector, that is OC minus OA. 1 minus 1, 0. 2 minus 2, 0. Minus 4 minus 3 minus 7. That is 0 I cap, 0 j cap, minus 7k cap. Then what is the area of the triangle ABC in vectors? We have learned this formula. Half modulus of A bar cross B bar. But A bar, B bar denotes what? Their adjacent sides. Here what are the adjacent sides? AB and AC. So half modulus AB bar cross AC bar. That's it.